Okay, not too many people today. Not sure where everyone is. Maybe they didn't get a message. Okay, so today we're going to talk about trigonometry, and have you all seen the assignment being published? Please let me know. Okay. Excellent. All right. Excellent. Have you managed to do any of the questions? Have you found anything super confusing? Please let me know. 1 and 2. Okay, good. And are you all familiar with SOHCAHTOA? So I assume you've done that in school. SOHCAHTOA. So you know what how can I receive all that? No, I got on my email. It's not an email. It was on Google Classroom. Not without it. Yes, but not without a calculator. Okay, so all right. So to access our materials, let me share my screen. Okay, people are joining. All right, excellent. That's good. Okay. So I'm sharing my screen. Sharing my screen. Right. So if you want to access our materials, so you have COMPOS. You go to the COMPOS website, and it says download assignment 02 here. And here you have a year 1011, assignment 1002. This is the one that we're doing today. Okay. Right. So, and of course, the whiteboard. The whiteboard is here. Okay. What is SOHCAHTOA and find sine 30? So this is a simple problem to start with. And how do you find sine 30? Does anyone know how to find sine 30 without any calculators or anything like that? So if you have a right angle triangle, and there's an angle, let's call the angle theta, a right angle triangle. If this is an angle theta, opposite over hypotenuse is always 30 degrees. Well, yes. Well, opposite divided by hypotenuse. So this is the opposite side. Opposite. This is the adjacent side. Adjacent. This is the hypotenuse. Okay. And we know that sine theta is equal to the opposite over hypotenuse. We know that cosine theta is equal to adjacent over hypotenuse. And we know that tan theta is opposite divided by adjacent. And this is SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Okay, so this is what you study in school, so you should be fairly familiar with it. But specifically, we need to find sine 30. Find sine 30 and not use any calculators or anything. Well, the way to do it is not very straightforward. So we start with a equilateral triangle. So we start with a 60-60-60 triangle. And let's say the side of this triangle is, well, I don't know, 2, 2, and 2. Yeah, does anyone have a question? Okay. 2, 2, and 2. We cut the triangle in half like this. And now we have two right angle triangles, the one on the left and the one on the right. So we take one of these, we take the one, let's say, we take the left one. We take the left one. And yeah, so it's like this. So what do we know about it? Well, we know that this is 2. We know that this is 2. We know that this is 1 because there's half of that. Can we work out the third side? Because this is 60 degrees. This is 90 degrees. So this has to be 30 degrees. So this is 30 degrees. And yeah, so if you want the sine 30 degrees is opposite divided by hypotenuse. So it's 1 divided by 2. What would be cos of 30? To find cos of 30, well, we need to find this side. And this side can be found using Pythagoras' theorem. So 2, if we need to find that side, is going to be x. So 1 squared plus x squared equals 2 squared. So x squared equals 3. X equals square root of 3. So this is square root of 3. So cos 30 is square root of 3 over 2. So this is how you find sine and cosine of certain angles without a calculator. Does this make sense? Does everyone understand what I did? On a scale of 0 to 10, please. And indeed, if you do sine 30 degrees, it is 1/2. And if you do cos 30 degrees, it is square root of 3 over 2. Hope that makes sense. Okay, so this is how you do, how you find that you could do this. You do a very similar thing for the 45, 90, 45 triangle. You just invent a triangle. Now, if we go back, like, why did I choose 2? Well, you could choose anything. It doesn't matter what you choose. It doesn't matter the side, because you could have the side could be A. If this is A, this would be A over 2. And if this is A over 2, then this x, so x would be A squared minus A over 2 squared, which is that, which is 3a squared over 4 square root, which is square root of 3 over 2a. And then you do 30 degrees, if you do sine 30 degrees, it's going to be a over 2 divided by a, so this divided by that, which is a half. And cos 30 degrees is going to be square root of 3 over 2a over a cancels, and we have square root of 3 over 2. The beautiful thing is that it doesn't matter if you have two similar triangles, cos sine 30 is always 1/2. It doesn't depend on the lengths of the sides. It could have any sides. The triangle can have any sides. Okay, so since you fully understand this, so let us move to the interesting stuff. Okay, so are you all happy with this? Are you all happy with SOHCAHTOA? Are there any questions? Because you need a solid understanding of this to move on. What is the trigonometric circle? Right. So this is it. So the point is we can always scale down any triangle. We can scale it down to a triangle with hypotenuse 1. And the angles will change. So for example, here, if you take this angle, let's call this angle theta, and call this angle theta, we can say sine theta is equal to 3 over 5. 3 over 5. And here, sine theta is going to be 0.6 over 1. 0.6 over 1, which is also the same as 3/5. I hope everyone knows that, understand that. 0.6 over 1 is the same as 3/5. So yeah, I mean, it doesn't matter. If you have a triangle whose hypotenuse is not equal to 1, all you need to do is just scale it down, and you'll have a triangle with hypotenuse 1. Okay, now we draw a quarter of a circle on the coordinate axes. So basically, this is literally, we have the x-axis, the y-axis. So x-axis, the y-axis, and what we do, if we find the point 1, we point to the point 1, and we draw a circle like that. Okay, so there's nothing extraordinary here. And then we draw an angle. We draw an angle like this. Could be any angle. So the angle theta. Right. And this is 1 because that's the radius of the circle is 1. And let's call this let's say B has coordinates x and y for now. That means that the length of this side is x, and the length of this side is y. Yeah, so for example, if B was, I don't know, if B was 4, 5, that means this would be 4 and this would be 5, right? Because that's how it works. If the coordinates of point B is x and y, that means this distance is 4, x, and this distance is right. And we find the sine of this angle. We find sine of this angle, sine theta, and it's opposite over hypotenuse. So opposite over hypotenuse, which is 1. So it's 1, y. And then we find the cosine of this angle, and it's going to be x over 1, which is x. So x is cos theta, and y is sine theta. So the coordinates of this point is cos theta and sine theta. I really want you to appreciate that. Let's have a look. I've made a model here. So this is a quarter circle. So literally, this is the coordinate axes. So this is a quarter circle. I couldn't do it. I didn't find how to do a quarter circle, but it doesn't really matter. And now I can move this. I can move this point. Okay. And let's make an angle of 30 degrees, or as close to 30 as we can. Otto, I will answer your question. Yeah, just in just a bit. Look at this. So if you have a circle of radius 1, and an angle, so in this case, this angle is 30 degrees. It's almost 30 degrees, angle 30. And it turns out that the coordinate of this point is going to be cos 30 and sine 30. And it says that the coordinate of this point is this. Let's check. Sine 30. Well, sine 30, we already know it's a half. So yeah, that is cos 30. Well, roughly, it is cos 30. I mean, this is approximate because it's a rough drawing, because I can't get 30 exactly. But if I were to get 30 exactly, I would get the exactly 0.5. And cos 30 is on the calculator 0.86602. They're really, really close. So it is, in fact, that. So if you want to find the cosine or sine of any angle, all you need is to draw that angle here. Like, for example, 70 degrees. 70 degrees, and that's going to be the cosine of 70 degrees is 0.34. And sine of 70 degrees is going to be 0.939. Let's check your understanding. What is cosine 0 degrees? What is cosine of 0 degrees? Please answer in the chat. Cosine of 0 degrees. So if I make this angle 0, one. It is 1, yes. Look, because if I move this and make it like this, you see it's 1, 0. So cosine 0 degrees is 1. And sine of 0 degrees is 0. So the coordinate of point D, is cosine of this angle, comma, sine of this angle. And this is like, it's marvelous. I don't know. This gets me excited because it's so cool. Okay, check your understanding again. What would be cosine of 90 degrees? if I make the angle 90, what is the cosine of this angle? Same 2 people answering, same 3 people. Yes, it is 0. Yes, you can see that it is 0. If the angle is 90 degrees, 0. Okay. I feel that there is there's some let's make a screenshot. So if you take a quarter circle, and this is a big deal, like, I mean, you really need to understand that. If you get a circle and you draw a line, you draw an angle, and let's say this is 22 degrees. 22 degrees. The coordinate of this point, the coordinate, is going to be cosine of 22 degrees and sine of 22 degrees. How well do you understand this? On a scale of 0 to 10, please. One, two, three, four, five. There are there's many more people in this room. Guys, don't be shy, please. If it's a 2, it's a 2. That's fine. If you're not understanding it, this is important information for me. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 people in this room. I've only got 9 replies. What do I assume? Do I assume 6 ones? Are there any instances where the radius of the circle would not be 1? That's a good question. You could always make it 1. This only works for circle of radius 1, of course. So any angle when drawn, when a circle of radius 1 is drawn around it, will have a cosine of x and a sine of the cosine of this angle is the x coordinate. The x coordinate, so this point has coordinates x, y. And it turns out that x is cos 22, is cosine of this angle, and y is sine of this angle. The proof is here. I've proved it here, and the proof is in the paper. But I really want you to understand what's going on. So yes, for circles of not radius 1, well, it doesn't work. For example, if you have a circle of radius 2, if the radius was 2 and this was 2, this would be 2 multiplied by cos 22 and 2 multiplied by sine 22. But that doesn't make it doesn't that just scales it up. Y over 10 be the sine. Yes, exactly. You're right, Vishaka. Yeah. So we don't need to bother with circles of other radius, because look, the point is we all can always make the hypotenuse equal to 1. We can always, any right angle triangle will scale down to make the hypotenuse 1. And if the hypotenuse is 1, the hypotenuse is the radius. And that's why hypotenuse is the radius. Hypotenuse is the radius of the circle. And that's why it's always 1, because we can always scale it down. Okay. So, if you draw a line at 45 degrees, no, so not 45, 60 degrees. If you draw a line of 60 degrees, you know what? I'll draw another one. If you draw a line of 60 degrees, the coordinate of this point, well, it turns out that the coordinate of this point is going to be 1/2 and square root of 3/2. What is cosine of 60 degrees? Question, what is cosine of 60 degrees? Checking your understanding. Very good. Is there anyone on here that doesn't understand how this means that cosine 60 degrees is 0.5? Is there anyone here who doesn't understand this? This because this is important. This is we need to nail this down. We need to be confident. And this also means that sine 60 well, no, that's not the point of putting it in the calculator. No, you don't put it in the calculator. You don't need to put it on the calculator. You look at the diagram. It turns out that when you draw a line at 60, it crosses this circle at point 1/2 square root of 3/2. This is what you need. This is the information that I'm giving you. This information. When you draw a line, when you draw a ray at 60 degrees, it crosses the circle at this point. And this means that cosine 60 is 0.5. This means that sine 60 is square root of 3/2, which is approximately 0.87. No, for the assignment, that's not what you do for the assignment. For the assignment, you draw the triangle. Yes, sorry, you draw the equilateral triangle, and that's what you need to do, and work out the angles. But I mean, we're not doing the triangle now. We're doing the circle. We are trying to link the angle and the circle together. Now, when you're confident with the circle, so basically, when you move this dot, the coordinate of point D, the intersection of this ray and the circle is this cosine and sine. So cosine and sine, they change as the angle changes. So cosine, so for example, for 45 degrees, the cosine and sine are the same, and it does make sense. 0.707, which is square root of 2/2. And then you move around like this. Now, the next section is trigonometric ratios for obtuse angles. So basically, what if we took this and increased the angle to I don't know, 120 degrees. Or as close to 120 as we can get. You can see that D has a negative x coordinate. It's negative 0.5. And this is plus. That's the beautiful thing about it. If you look at the assignment, the section is called Trigonometry without triangles. We don't need the triangle anymore. Okay, so here it is. We can find sine and cosine of obtuse angles using the circle. For example, for 120 degrees, cosine is minus 0.5 and sine is 0.87. The question was, what is sine 150? So let's drag this up to 150. So this angle is 150 degrees. So this is 150 degrees. And this point has coordinates minus 0.87 cos 0.867 and 0.5. So what is cos 150 degrees? Very good. It is negative 0.867. Well, it's actually minus square root of 3 over 2, which is approximately minus 0.867. What is sine 150 degrees? Well done. It is 0.5. 0.5. And what is tan 150 degrees? Well, with tan, it's interesting because we know that tangent is equal to sine theta divided by cos theta. You can use this. So tangent 150 is going to be sine 150 divided by cosine 150. And we know that the sine is 150 is 0.5, and cosine 150 is minus square root of 3 over 2. And if you do this, this is going to be 1/2 divided by minus square root of 3 over 2, which turns out to be minus 1 over square root of 3, which can be simplified as minus square root of 3 over 3. So tangent 150 is minus square root of 3 over 3. Let's check. Tangent 150. True. Works. Any questions? Any questions? Now, in our assignment, we will ask you to find the exact values. So just to give you a little hint, when doing the assignment, first make a table. So sine, so the angle, sine angle, cos angle, and tan of the angle. So make a table for yourself, starting with 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Fill this table because you'll really need it throughout the assignment. I mean, you can cheat a little, you can use technology to fill it. So sine 0 is 0. Sine 30 is a half, etc. Sine 45 is square root of 2/2, because you will need those, etc. So fill the table, just a really good thing to start with. And then, yeah, that's what you do. So we can find cos 150, sine 150, and tan 150 by just looking at the triangle. So how would we do this without a circle? Yeah, you don't have this. So how do you do it? Well, you say, okay. So what is 150? Well, if you draw a circle, then yeah, this is 0 degrees, this is 90 degrees, and this is 180 degrees. 150 degrees is somewhere here, because the angle is always measured from the positive x-axis. And 150. We use symmetry. Well, if we draw a symmetrical line, it's going to be this one. This is going to be 30 degrees. So this is 30 degrees. And we know cosine 30. We know that the coordinate of this point is square root of 3/2, comma 1/2. We know that because we know cos 30 degrees is square root of 3/2, and we know that sine 30 degrees is 1/2. Therefore, but this point is symmetrical. It's symmetrical to this point. So the coordinate of this point is going to be minus square root of 3/2, comma 1/2. That's how you do it. That's how you do it without a calculator, without a circle, without actually drawing a circle. The method that I've shown you is just to check yourself. So let's say, okay, let's do these. Problem 4. Okay, so I'm gonna switch them around. I'm gonna do first do cos 180, cos 270, sine 270, sine minus 90, and sine 300. I'm gonna switch them around. So for these questions, we need to memorize that table. Yes, you need to, well, yes, you do need to memorize that table. But I mean, the first problem, is it the first problem? The second problem is actually, if you do the second problem, that's your table. That's pretty much your table, except for 0 and 90 degrees. All right, so cos 180. So let's work that out. So cos 180. So we draw a circle. We draw an angle of 180 degrees. So we always start with from here, from the positive x-axis. So 180 degrees, that's this angle. Yeah, so this is 180 degrees. And the coordinate of this point, what is the coordinate of this point? Minus 1, 0. Yes, minus 1, 0. That means that cos 180 is minus 1, and sine 180 is 0. Oh, we needed cos, so cos is minus 1. Easy, right? It's like if you type E if you think it's easy, and type H if you don't find it easy. As long as you understand the principle. Okay, so 270. 270. So you have 0, 270. So you go 270 is going down here. You go all the way here. This is 270 degrees. So what's the coordinate of this point? 0 minus 1. So what is cosine of 270? 0. Cos 270. 0. And sine 270? 270 is minus 1. And tan 270, if they ask you for tan 270, tangent 270, well, it's sine over cosine, so minus 1 over 0. It's undefined. Minus 1 over 0, that's undefined. Undefined. All right, sine 270, well, we already, so cos 270 is 0. Sine 270 is minus 1. Sine minus 90, so that's an interesting one. Minus 90, that means that we're going the other way, because positive means we're going anti-clockwise. Negative means we're going clockwise. So we are going the other way. So we're going clockwise minus 90 degrees. Negative means clockwise. Negative is clockwise. Therefore, it's the same point. It's the same point, is 0 minus 1. So what is sine minus 90? Minus 1. Well done. Okay. So we've established that. So now we deal with slightly harder ones, which are not on the axes, but it's still very, very doable, because 300. So 300 is all the way around, the circle up to here. So this is 300 degrees. 300. But if this is 300, that means this is 60. And we know that this is 60. We know the coordinates of this point. And the coordinates of this point, because it's going to be 1/2, comma, square root of 3 over 2. So what is the coordinate of this point? We already know this from the table. Yes, we know this. We know this. this from the table. So because they have the same x coordinate, it's not going to be negative. It's going to be 1/2 because x is the same. It has the same x. 1/2, comma, minus square root of 3/2. Yeah, you understand that? So what is sine 300? Minus square root of 3/2. So what I want you to do is I want you to be able to work with this circle and really, really understand it. Let's have a look. So we had 150. So now we go 300 degrees. 300 degrees. And yes, beautifully, it's 0.5 and minus 0.863. Minus square root of 3/2. That is what's the synonym for cool? Because I've used the word cool too many times today. All right. Let's skip to question 6, the tangent axis. Now, similarly to what we did before, that if you draw a line like this, the coordinate of this point is the sine and cosine. But if you draw a vertical line here, the y coordinate of this point, so the coordinate of this point is going to be 1, comma, tan theta. So if the coordinate of this point, so if this angle is theta, and the coordinate of this point is cos theta, comma, sine theta, then the coordinate of this point is going to be 1, comma, tan theta. And Manish, which part do you not understand? The whole thing or just the 300? 300. Well, so going from here, 300 is here. So the coordinate, it's going to be the same as for the 60 degrees because 60 degrees is symmetrical. We're using symmetry here. We know that cosine, we know the coordinates of this point. We know for 60 degrees, this is 60 degrees, and this is 300 degrees. We know that these points are symmetrical. And we know from previous experience that the coordinate of this point is that. Therefore, well, if this is the x-axis, if we flip over the x-axis, the x stays the same, but the y changes. The y changes to negative. Right? So if you have 2 points, for example, which are symmetrical, if you have 3, 4, this would be 3 minus 4. Right? So if it's like a mirror line. So if you know the coordinate of this point, the 60 degrees, so you know the coordinate of 300. 300 is. Yes. This is the whiteboard. Okay, so moving on to problem 6, the tangent axis. If we draw a line through point 1, 0, 1, 0, then the coordinate of the intersection of this line, so this line we can move, and where it crosses the axis, that is the tangent. It's quite cool. I mean, let's draw a line. So a line. Okay. And a point. A point here. Okay. By the way, I'm pretty sure I can. Oh. Do I need to? Not sure. Oh, GGB file. I'll see if I can share it. Can I share it? Hate editing videos afterwards. Anyways, so if you move this, if you move this, you can see that the this point changes the coordinates. The coordinate of this point changes. The D point changes, but also the coordinate of this changes as well. And for example, if you want tan 30 degrees, so you draw 30 degrees, and this is going to be the tan of 30 degrees. Okay, so if this angle is 30 degrees, the coordinate of this point is going to be cos 30 degrees, comma sine 30 degrees. But this point is 1, comma tan 30 degrees. Let's see if it actually makes sense. Tan 30 degrees. So tan 30 degrees is 0.577. 0.5773. All right. Okay, so I see discussions about the marks. I think we've graded like 70% of your assignments. So if you haven't received your score, don't worry, we will. In terms of emails, you will receive an email with your scores. Okay. Yeah, so they are marked separately by different people. So don't some of you will have received your score, some of you won't. You will receive an email at the end of this week. You will receive an email saying that your score and whether you're in or not. Okay, so yeah, you will receive an email if you didn't get in. Although we didn't have as many submissions for year 10 and year 11 as we wanted to. So it looks like a lot of we can accept quite a few people, which is good. Quite a few. Right. So this is what the tangent axis is all about. The proof is in the assignment. I'm not showing you the proof. I'm just showing you what it means. So this we call this the tangent axis. The tangent axis, because yeah, tangent axis, and that's the vertical line. The tangent axis is the line x equals 1. I really don't have great boundaries, but I've got a feeling that if you did a decent, we're discussing the grade boundaries tomorrow, so I can't really comment on that. Why is it 1 in the y bit? What do you mean why? No, x is 1. Well, x is 1 because it is 1, because no matter where you are, it's going to be 1. If you move this line, the intersection is always going to be 1. But the y changes. Y is the tangent. This meeting, we are going through assignment 2. We are going to trigonometry assignment 2. Sorry, maths assignment 2, which is trigonometry. Well, there will be a recording in a couple of hours because I will have to edit a few things out of this video. Okay. Now, how much time do we have? The reduction formulae, I'm not sure if I want to go into that. Maybe if we have time later on. If there are people who don't get in, we'll still have webinars. Yes, affirmative. You will still have me every week. Okay, trigonometric identities. This is the biggest, widest topic in trigonometry. And it all breaks down to algebraic manipulation. So it looks scary, but all you need to memorize is the basic stuff. So what trigonometric identities will I need? You will need to memorize, to know and understand. I'm not using the word memorize because we're not memorizing stuff. We are learning and understanding stuff. You need to know and understand that tan theta is a fraction, which is sine theta over cos theta. That's the first thing. Let's make it. Okay. You will need to know that sine squared theta plus cos squared theta is 1. Very important. You will need to know that sec theta is 1 over cos theta. And cosec theta is 1 over sine theta. Yes, they are written. They're all written in the assignment. And okay, and the last one is cotan. Cotan cot theta. Cotangent theta is cos theta over, oh no, over sine theta. Cos theta over sine theta. We won't be using the last one today, but we will, and the second one. So we will be using this one, and this one. There's an explanation in the assignment. Okay, so I'll leave the fun bit exploring that to you. Just remember, these are trigonometric functions. We have sine, cos, tan, cotan, cosec, sec. Do you have anything else? No, that's pretty much it. These are different trigonometric functions. Okay, so I'll leave the fun bit to you. Well, sec is hypotenuse over adjacent. Cosec is hypotenuse over opposite, and cotangent is adjacent over opposite. If you like. Anyway, when you're doing when you are simplifying when simplifying or proving identities, you need to break down into the most basic. So usually when with expressions, you need to break down into sine, and cos. What does that mean? Is there a word like SOHCAHTOA for sec, cosec? No. By the time you reach sec and cosec, you don't use mnemonics. Let's put it this way. Yeah, I mean, sec and cosec are studied in year 13, I believe. And yeah, just at that time, you should be very confident with what sine cosine is. So no, not really. I have mocks coming up. I cannot do this as well as my test. My test finished on the 14th. We physically cannot do both. All right, I have mocks coming. I cannot do this as well. It's my test. My test finished on the 14th. Cannot do both. Well, okay, Dania. Look, you to complete COMPOS, you need to do 70% of the assignments. So if you're in and there are forces preventing you from submitting assignment 2 on time, you let us know and saying that I'm incredibly sorry that I won't be able to do assignment 2, or yeah, you can do it later on. You can submit it later on. Yeah. So if you have a valid reason for missing assignment 2, we allow this basically. If you skip 2 assignments, then probably no. That probably means we'll to give your place to someone else. But yeah. So don't. It's just talk to us. Let us know, and we will. Yeah. We will be able to work around this. Okay. So what happens is when you get an email. So you get an email that you're in. If you get an email that you're in, you will have a tutor. You'll need to the tutor will communicate with you. You will have tutorials with your tutor, and you tell them, you let them know that this is what's going on, and that you have a mock exam on the, and you can't do it. But you still have 3 weeks to do it. But I mean, okay, sure, I understand. You're probably year 11, right? So yeah. Okay, so you need to break down into sine and cos. So here you see sec and tan and sec and tan and tan. So basically, you want to express everything in terms of sine and cosine. So you're using these identities. So sec is 1 over cos, and tan is sine over cos. So we're going to use that. We are going to write this down. So open bracket, 1 plus sec. And we know that sec is 1 over cos, cos theta. We know that tan is sine over cos. So you're going to be plus sine theta over cos theta. Open bracket, 1 minus sec. Sec is 1 over cos theta plus sine theta over cos theta. I'm not touching the right-hand side. I'm just working with the left-hand side for now, left-hand side. I'm going to simplify this. So what can I do? Well, the 3 fractions, well, 3 terms, I can find the common denominator. The common denominator is cos theta. So I multiply this by cos theta, and I have cos theta plus 1 plus sine theta over cos theta. I don't need brackets anymore, so I drop the brackets, and here it's the same cos theta, and I multiply this by cos theta, so it's going to be cos theta minus 1 plus sine theta. Does this make sense? Does everyone understand what I did? On a scale of 0 to 10, please. Do you understand what I did here? I found the common denominator. Okay. I'll repeat my question, but now let's drop this for now. Do you understand what I did here? On a scale of 0 to 10. Okay, you understand this. Because sec is literally 1 over cos theta, and tan is sine. So I just replaced it. Okay, so everyone understands this. Okay, I want to find the common denominator. The common denominator, when I'm adding fractions, for example, if I want 1/3 plus 2, I need the common denominator. The common denominator is 3. So I rewrite this as 1 over 3 plus 6 over 3. And now I can add. Right? That's what I do with fractions. So the common denominator is cos theta. So I can write cos theta over cos theta. This is 1. Yeah, cos theta over cos theta is 1. Plus 1 over cos theta plus sine theta over cos theta. Yeah? Are we clear on that? Any questions here? All right. And here we have the same cos theta over cos theta minus 1 over cos theta plus sine theta over cos theta. All right. So now I join the fractions together. I have cos theta plus 1 plus sine theta over cos theta. I join them together into one fraction, multiplied by cos theta minus 1 plus sine theta over cos theta. Is this clear now? Do you understand now? And that's what I had. But now I can delete it. Right? Now, using the rules of multiplying fractions, I can I multiply the denominators, and that's going to be cosine squared theta, because when you multiply fractions, the denominators multiply. And on the top, I have cos theta plus 1 plus sine theta multiplied by cos theta minus 1 plus sine theta. Okay. Here I don't have to be very clever here. I'll just multiply them out. I multiply the top out. So multiply cos by cos, cos by minus 1, cos by sine, and then do it 9 times basically. So cos squared theta. Cos squared theta, then minus cos theta, plus sine theta cos theta, plus cos theta, minus 1, plus sine theta, plus sine theta cos theta, minus sine theta. Cos theta squared is the same thing, yes, as cos squared theta. Minus sine theta plus sine squared theta. All right, so what do we have? So cos and sine cancel. Oh, sorry, what am I saying? Cos and minus cos and plus cos cancel. Sine and minus sine cancel. All right. So what do we have? We have cos squared plus sine squared. So we have cos squared theta plus sine squared theta minus 1 plus 2 sine theta cos theta divided by cos squared theta. So I've just expanded the brackets and I simplify. So I'm not doing anything extraordinary. Look, trigonometry at its finest is just algebra. Yeah, it's just working with algebraic fractions. But who recognizes this? Who recognizes this bit? Sorry, that's not what I meant. That's not what I meant. So yeah, so who recognizes this? It's 1. Remember, it is 1. Cos sine squared is 1. So it's going to be 1 minus 1. So this thing is equal to 1. So 1 minus 1 is 0. So this is going to be 2 sine theta cos theta divided by cos squared theta. And cos squared theta is cos theta cos theta. Cos cancels, and we have 2 sine theta over cos theta. And sine theta over cos theta is tan. So it's 2 tan theta, which is QED. I keep forgetting QED meaning. Quod erat demonstrandum. Quod erat demonstrandum. Which was to be demonstrated. Which was to be demonstrated. QED. Quod erat demonstrandum. Which was the original question, 2 tan theta. That's what we needed to prove. Okay. The next one is harder. So don't worry if you don't get it. You will need to watch the video again if you want to, but I'll go fairly quickly with this one. Show that for any permitted theta, obviously that for some thetas you can't find, you will have division by 0, right? So that's why you don't always, for any permitted theta, that's what it means. Okay, sine to the power 4 theta plus cos to the power 4 theta minus 1 over sine, that's equal to 2/3. Okay, obviously we're going to work with the left-hand side because it's easy. It's easier to turn this into that rather than turning 2/3 into that. Making 2/3 into that would be probably hard. Oh, so what do we do here? We want to work with the left-hand side, and it's sine to the power 4 theta plus cos to the power 4 theta minus 1 sine 6 theta plus cos 6 theta minus 1. It sure does look scary. To help us, we need to be very creative. We know that sine squared theta plus cos squared theta is 1. Now we can square both sides. Square both sides. We have sine squared theta plus cos squared theta squared is equal to 1 squared, which is sine to the power 4 theta plus 2 sine squared theta cos squared theta plus cos to the power 4 theta. And that's equal to 1. In other words, rearranging this, sine to the power 4 theta plus cos to the power 4 theta is equal to 1 minus 2 sine squared theta cos squared theta. We're going to use this in a bit. Rearranging. Arranging. All right, does everything make sense so far? What I did? Does everyone understand? Is everyone on board what I just did here? Now, similarly, Instead of squaring both sides, I'm going to cube both sides. And I'm going to have sine squared theta plus cos squared theta cubed equals 1 cubed, which is also, this is really advanced stuff. Okay, so this will help you do the hardest questions in the assignment. And by hardest questions, I mean, where are they? So this is this is 11, 10, 11, 12, 13. Actually, yeah, it definitely will help you. 10, 11, 12, 13. Cube both sides. And, well, we need to use the formula. We need to use the formula a plus b cubed. We know is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. This is something that you suppose you know, okay? You can find proof of that online. I'm not going to go very deep into that. But it is binomial theorem. Yes, thank you. It is Pascal's triangle. Oh, nice. Nice, it is, by all means. So I'm going to cube this. So if I cube both sides, it's going to be sine to the power 6 theta plus 3 sine to the power 4 theta cos squared theta plus 3 sine squared theta cos to the power 4 theta plus cos to the power 6 theta. And that whole thing is equal to 1. I'm going to join these together. I'm going to find the common factor. So sine to the power 6 theta plus 3. Now I can take sine squared theta cos squared theta out of the brackets. And inside the brackets, I'm going to have sine squared theta plus cos squared theta. Ooh, beautiful. Cos to the power 6 theta equals 1. This thing turns out to be 1. So we're left with sine to the power 6 theta plus 3 sine squared theta cos squared theta plus cos to the power 6 theta is equal to 1. Rearranging, we have sine to the power 6 theta plus cos to the power 6 theta is equal to 1 minus 3 sine squared theta cos squared theta. I'm going to use that as well. So, taking all of this on board, the left-hand side, and putting this into that, we can write 1 minus 2 sine squared theta cos squared theta minus 1 over 1 minus 3 sine squared theta cos squared theta minus 1. 1 cancels. 1 cancels. We're left with minus 2 sine squared theta cos squared theta over minus 3 sine squared theta cos squared theta. Cancel, 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 cancel. 2/3. Q, E, D. Okay. Just It's not an. You don't have to add the QED. No, this is just. I'm proud of myself, and I'm giving myself a QED. In fact, it is equal to for any. So this thing. So no matter what theta is, no matter what theta is, it will be equal be 2/3. The expression will be 2/3. The left-hand side will be 2/3. It is an identity, and you could draw it like this with 3 dashes. All right, so it's always equal to. So 3 lines means always equal to. Equal to. And just a moment of like a philosophical. So what does that mean? What's the difference between this and this? Well, you could have, for example, 2x plus 3 equals to 11. This is true when x is 4. Yeah. This is true for when x is 4, but not true when x is not 4. Yeah. So this is not true when x is 7, for example, because when it's 7, it doesn't work. So it works for x equals 4, but doesn't work for other values. Whereas an identity, for example, 2x plus 3 and 4x plus 6 over 2, it always true. Always true. For any x. This is the difference between equation and identity. Difference between equation and identity. When we do equations, we write equal. When we do identity, we get 3 marks. Okay, you can use the double instead of triple, but you can't use the triple instead of double, if that makes sense. Okay. Okay. Any questions? Did you find it useful today? That's a question for you. Did you find it useful to go through that? Happy to hear. Okay, so I hope this will give you a good start. So those of you who get a place on for COMPOS next week, you are supposed to have your first tutorial with a tutor. Okay, and also next Tuesday we have a launch webinar. A launch webinar, we will invite your parents to attend as well. So it's going to be a webinar with me. I will go through the expectations. I will go through the rules of COMPOS, and then we'll do an hour on physics. Okay. Am I one of the tutors? Well, no. Short answer is no. The tutor, I select the tutors, I train them, and I'm sort of in charge of the tutors. But the times of tutorial sessions, we will ask you a question, what time you are available, And then we will ask you a question when we'll ask you when you're available, and we will ask the tutors when they are available, and then we'll sort that out. So if you are a state school student, it is entirely free to you. If you study in a private school, or if you live abroad, you pay a small and not a very big fee. You pay £25 per week. Okay, but if you are a state school student in the UK, it's free to you. Okay. If you have bursaries, you need to let us know. We do have a bursary program as well. 1 tutor lesson per week, yes, and one with me. Yeah. Bursary is when so some private schools have bursaries. Basically, if you are really good, you qualify for free tuition at a private school, and you do exams. It is decided on a case-by-case basis, and yeah. So if the school feels that they pay your tuition, the school itself, from their own money, pays your tuition. Okay. Just like we do for all our state school students, we pay your tuition because it's not free. It's free for you. It's not free for us, because we have a lot of tutors, etc. etc. It is a scholarship, yes. A bursary is a sort of a scholarship. Okay, brilliant. Then, well, we unfortunately with assignment 1, we don't have capacity to do corrections. We just give you the marks for each question. Yeah. Somebody's asking, are there other trigonometric identities? Yes, there are literally thousands of them. Okay, there are literally thousands of trigonometric identities. Like the ones that we did are trigonometric identities. It's just 2 out of the very many. So yeah. Okay, brilliant. So I'll see you next week. And for next week, those of you who are in, we will invite your parents as well to join us for the first half hour of the webinar. All right. Okay, see you then. You can attend webinars even if you don't get in. You can still come to webinars. You can still download our assignments, and you can join us next year when you know how it works. And if you do the assignments on your own and you send them to me at the end of the year, you will also receive well, it's not a certificate, but it's a letter of completion that you have completed COMPOS, just like everybody else who does COMPOS. So yeah, it's something worth considering. Although if you, honestly, if you can do all of our assignments, you'll probably get in anyways. If we do this, can we do the year 11, 12, and 13? Yes, of course. If you do well this year, you won't need to compete for a place next year. You automatically get a place next year if you do well this year. By well means that you attend tutorials, you do at least 70% of the assignments, and yeah, that's All right. Enjoy. See you.